Welcome back friends. Welcome back to another video session from this channel. So in this video session we are going to study about wobble hypothesis. So what are the various salient features of wobble hypothesis and what are the various strategies which are in association with wobble hypothesis in detail. So here, before studying about wobble hypothesis in detail, at first we should have a basic idea regarding the interaction which is organized in between the codon of the mRNA and anticodon of the tRNA, right? So let me write it here. Codon and anticodon interaction, right? So here, if we consider all the nucleotides which do exist in nature, either in case of the DNA or RNA, they obey the normal Watson-Crick base pairing, right? So let me write it here. Watson-Crick base pairing, right? Watson-Crick base pairing. So here, for your better understanding, let me present the nucleotides which do exist or which do obey the Watson-Crick base pairing or the normal base pairing, right? So here the complementarity of adenosine is T in case of the DNA, but whereas in case of the RNA it is U. And in the same way the complementarity of T is A, the complementarity of G is C, and the complementarity of C is G again. So all the nucleotides which do exist either in case of the DNA or RNA, they obey the normal Watson-Crick base pairing. And in addition to the normal Watson-Crick base pairing, in case of the RNA, there is an availability of one more other unusual base pairing. And that specific unusual base pairing, it is nothing but what? Wobble base pairing, right? So let me write it here. What it is? Wobble base pairing. Right? So here let me present you the various nucleotides which obey the wobble base pairing, right? So here the very first nucleotide, it is nothing but U, C, A and G. So here the specific uracil nucleotide, it is capable to encode the various nucleotides like A or G or I, and in the same way the cytosine nucleotide, it is capable to encode the various nucleotides like G or I, and in the same way the adenosine nucleotide, it is capable to encode the various nucleotides like U or I, and in the same way the specific guanosine nucleotide, it is capable to encode the various nucleotides like C or U, right? So all these are the various nucleotides which are a part of the codon of the mRNA, right? Codon of mRNA. And all these are the various nucleotides which are a part of the anticodon of tRNA. Right? So here we need to understand about the wobble base pairing. So what is the uniqueness or what is the beauty of wobble base pairing here, right? So here if we consider one specific mRNA, right? So let me erase the things here. One specific mRNA which possesses or which contains one specific codon which is nothing but ACI. So let us we assume it is the mRNA, right? So in case of the mRNA, there is one specific codon which is nothing but ACI. So here the specific codon of the mRNA is capable to encode the various anticodons like ACI, right? So here it is 5' and it is 3'. And here the specific codon of the mRNA is capable to encode with the various anticodons like the complementarity of A is U, the complementarity of C is G, and here the specific inosine nucleotide, it is capable to encode with 3 nucleotides, right? So as I have already told you, the specific inosine nucleotide, it is capable to encode the various nucleotides like U, C and A. So by taking this point into consideration, here the specific inosine nucleotide, it is capable to encode with U. And in the same way, U again it is G, and here the specific inosine nucleotide, it is capable to encode with C. And again it is U again it is G, and here the specific inosine nucleotide, it is capable to encode with A. So here the specific codon of the mRNA, it is capable to encode with only one particular anticodon of the tRNA. But here, due to the presence of one unusual base, the specific codon of the mRNA, it is capable to encode with three different anticodons of the tRNA. And as we all know, each particular anticodon of the tRNA, or each particular anticodon, it is very specific to one particular tRNA here, right? One particular tRNA. And each particular tRNA, it is very specific to one particular amino acid. So here, due to the presence of one unusual base, here the specific codon of the mRNA, here it is base paired with three different anticodons of the tRNA and even with three different amino acids. So here it is due to the presence of unusual base. One particular codon of the mRNA, it is capable to encode with three different anticodons of the tRNA and even it is capable to encode with three different amino acids. So that is the uniqueness, or that is the beauty of the wobble base pairing here, right? So here, according to the wobble base pairing, there are certain rules. So right now we are going to discuss about the various wobble base pairing rules, right? So according to wobble base pairing, there are certain strategies, right? There are certain rules. So right now we are going to study about the various wobble base pairing rules. So what are the various wobble base pairing rules here? So according to wobble base pairing, when an amino acid, when it is encoded by more than one codon, the variation always it relies only at the 3' end but not at the 5' end. So let me present it here. Let us assume one specific amino acid known as alanine, right? So alanine is the amino acid which is encoded by various codons like 5' GCU, 3' 5' GCC, 3' 5' GCA, 3' and 5' GCG, 3'. So in all the various codons, which are engaged or which are encoded by the alanine amino acid, here the variation is present only at the 3' end but not at the 5' end. So if you look at here it is U, here it is C, here it is A, and here it is G. But the first two nucleotides, in all the codons, they are very similar. Here it is GC, 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 GC. That means according to wobble base pairing or according to wobble hypothesis, when an amino acid, when it is encoded by more than one codon, the variation always it relies only at the 3' end but not at the 5' end. And the first two nucleotides, they are responsible for inducing the specificity, and the last nucleotide, it is responsible for providing the variation. So it is one of the postulate of wobble hypothesis. And what is the other postulate of wobble hypothesis? As I have already told you, when an amino acid, when it is encoded by more than one codon, the variation relies only at the 3' end but not at the 5' end. For suppose, let us assume in case of the one particular codon, the variation is present at the first two nucleotides. So in such case, that particular codon of the mRNA, it is capable to encode, or it is capable to participate in the translation mechanism by taking the advantage of one specific tRNA or one more other specific tRNA. Most commonly, the variation relies only at the 3' end but not at the 5' end. For suppose, if there is any variation in the first two nucleotides of the codon of the mRNA, under such condition, that specific codon, it takes the advantage of one more other specific tRNA, right? So it is one of the postulate of wobble hypothesis. And the last postulate of wobble hypothesis, it is nothing but there is a requirement of 32 tRNAs. There is a requirement of 32 tRNAs. So according to wobble hypothesis, for organizing the translation mechanism or the translation process, either in case of prokaryotes or in case of the eukaryotes, there is a requirement of 32 tRNAs. So out of 32 tRNAs, one specific tRNA, it is responsible for initiating the translation mechanism, and another 31 tRNAs, they are capable to encode with 61 sense codons. 61 sense codons, right? The 61 sense codons which are present in case of the mRNA. As we all know, there is an availability of 64 codons. So out of 64 codons, 3 codons are stop codons or the termination codons. They are not recognized by any specific tRNA which do exist in nature. And there is an availability of only 61 sense codons. So for encoding 61 sense codons, there is a requirement of 31 tRNAs. And one specific tRNA, it is responsible for initiating the translation mechanism or the translation process, either in case of the prokaryotes or in case of the eukaryotes. So this is about wobble hypothesis, the various strategies of wobble hypothesis or the various salient features of wobble hypothesis in detail. I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.